Hi, young mathematicians! Bill Nye here, and today we're diving into the fascinating world of circles. Circles are everywhere you look. From the wheels on your bike to the moon in the night sky, circles are a fundamental shape in our universe. We use circles in so many ways. They help us tell time with clocks. They help us play games with balls. Get ready to learn about a cool rule about circles. It's called the alternate segment theorem. Before we tackle the theorem, let's get familiar with some important circle vocabulary. First up, we have chords. A chord is a straight line that connects 2 points on a circle's edge. Think of it like a bridge across a circular pond. Now imagine drawing a chord across a circle. You've divided the circle into 2 pieces, right? Each piece is called a segment. The alternate segment theorem is a fascinating geometric rule that deals with angles within a circle. It's a concept that might seem a bit daunting at first, but once you break it down, it's actually quite straightforward and elegant. You might think it sounds complicated, but trust me, it's simpler than it appears. This theorem is all about understanding the special relationship between certain angles formed by a tangent and a chord in a circle. So what exactly does this theorem tell us? It explains the relationship between an angle formed by a tangent and a chord at the point of contact, and another angle that is seemingly hiding in a different part of the circle. This hidden angle is what makes the theorem so intriguing. Are you ready for the big reveal? Let's dive deeper into this concept and see how it all fits together. The alternate segment theorem states that the angle between a tangent and a chord through the point of contact is equal to the angle in the alternate segment. This means that if you draw a tangent to a circle and a chord from the point where the tangent touches the circle, the angle between the tangent and the chord will be equal to the angle in the opposite segment of the circle. This relationship is not only fascinating but also very useful in solving various geometric problems. Let's break down this theorem into smaller bite-sized pieces. Tangent. Imagine gently placing a ruler against the edge of a circle. That ruler represents a tangent, a line that touches the circle at only one point of contact. This is the exact spot where the tangent grazes the circle's edge. Alternate segment. Remember how our chord divided the circle into 2 segments? The alternate segment is the segment that doesn't contain the angle formed by the tangent and the chord. Section 5. Picture this. Visualizing the alternate segment theorem. In this section, we will use our imagination to make sense of a fundamental concept in geometry. Let's create a mental picture to help us remember this theorem. Visualization can be a powerful tool in understanding and retaining complex ideas. Imagine a cheerful sun shining its rays down on Earth. The sun represents a point of light and warmth, much like a central point in our geometric diagram. The sun's ray is like a tangent, touching the Earth, our circle, at one point. This single point of contact is crucial in understanding the relationship between the tangent and the circle. Now picture a rainbow, our chord, arching across the sky, connecting to the point where the sun's ray touches the Earth. The rainbow represents a line segment within the circle, connecting 2 points on its circumference. The angle between the sun's ray and the rainbow is the same as the angle formed by the rainbow in the opposite part of the sky. This is the essence of the alternate segment theorem. The angles formed by the tangent and the chord are equal to the angles in the alternate segment of the circle. By visualizing this natural phenomenon, we can better grasp the geometric principles at play. So next time you see a rainbow, remember the beautiful connection it has with the sun's rays and the angles they form. Section 6. Proving the theorem, a step-by-step guide. In this section, we will delve into the fascinating world of geometric proofs, specifically focusing on the alternate segment theorem. This theorem is a fundamental concept in geometry, and understanding it can greatly enhance your problem-solving skills. Mathematicians love to prove things. The joy of discovering and proving theorems is what drives many mathematicians. It's like solving a complex puzzle where every piece fits perfectly. Today, we will experience this joy by proving the alternate segment theorem together. Let's walk through a simplified proof of the alternate segment theorem. Draw a circle. The circle is a fundamental shape in geometry, representing perfection and symmetry. Using a compass, draw a circle on your paper. Start with a beautiful, perfectly round circle. Ensure that the circle is as perfect as possible, as this will make the subsequent steps easier to follow and more accurate. Add a tangent and a chord. A tangent is a line that touches the circle at exactly one point, while a chord is a line segment with both endpoints on the circle. Draw a tangent touching the circle and a chord intersecting the tangent at the point of contact. Connect the center. This step is crucial as it sets up the geometric relationships we will explore. Draw a line segment from the center of the circle to the point of contact. This line segment is known as the radius, and it plays a key role in our proof. This line segment is perpendicular to the tangent. Create a triangle. The perpendicularity of the radius to the tangent is a well-known property in geometry. Connect the center of the circle to one of the endpoints of the chord. By doing this, you form a triangle within the circle, which will help us in our proof. You've formed a right triangle. Identify angles. The right triangle is a powerful tool in geometry, and identifying its angles is the next step in our proof. Notice that one angle of the right triangle is half the angle at the center of the circle. Apply angle rules. This relationship between the angles is a key insight that will help us prove the theorem. Remember that the angles in a triangle add up to 180 degrees. This fundamental property of triangles is essential for our proof. Use this fact, along with the properties of isosceles triangles, to prove that the angle between the tangent and the chord is equal to the angle in the alternate segment. The properties of isosceles triangles, where two sides are equal, will help us establish the necessary relationships between the angles. By carefully applying these properties and the angle sum rule, we can successfully prove the alternate segment theorem. This theorem not only deepens our understanding of geometry, but also showcases the beauty and elegance of mathematical proofs. Section 7. Putting it to the test example problem 1. Time to put our knowledge into practice. Let's say we have a circle with a tangent forming a 60-degree angle with a chord. What is the measure of the angle in the alternate segment? Thanks to the alternate segment theorem, we know that the angle in the alternate segment is also 60 degrees. Section 8. Mastering the theorem. Example problem 2. Let's try a slightly trickier problem. Imagine a circle with a tangent and a chord. The angle in the alternate segment is 40 degrees. What is the measure of the angle between the tangent and the chord? You guessed it! The angle between the tangent and the chord is also 40 degrees. Section 9. Geometry is fun, interesting facts about shapes. Geometry is full of fascinating facts. Did you know the word geometry comes from the Greek words geo, meaning earth, and metron, meaning measurement? A circle has an infinite number of lines of symmetry. The ratio of a circle's circumference to its diameter is always pi, approximately 3.14159. Section 10. Conclusion: the power of the alternate segment theorem. The alternate segment theorem is a powerful tool that helps us understand the relationships between angles within circles. By mastering this theorem, we can solve geometric problems and unlock the secrets of these fascinating shapes. Section 11. Keep exploring. Geometry is an adventure. Congratulations, young mathematicians! You've journeyed through the world of circles, segments, chords, and the alternate segment theorem. Keep exploring the exciting world of geometry. There's always something new to discover.